Assalamualaikum everyone. We are from group T5CS1102F. Welcome to our video presentation for MAT183. Before we begin, let us introduce our team members. My name is Nur Amshah Shazwan bin Shah Shah, and presenting alongside with me today are my teammates Muhammad Arif Izzuddin bin Muhammad Jamil and Muhammad Hamdi Zarif bin Abdul Ahir. Today, we are excited to walk you through some fundamental concepts of differentiation and solve a couple of practical estimation problems. So, what is differentiation? Differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding the derivative of a function. Depending on the function we face, we use various techniques. This include finding the derivative of constant, linear and power, implicit differentiation, also product rule, derivative of trigonometric, exponential and logarithmic function, chain rule, and lastly is quotient rule. So let's go to example of questions. So the first question, we are given the function of fx equals to square root 4x square minus 7, and our goal is to estimate the value of f 2.01 using differentials, rounding our final answer to 3 decimal places. First, we rewrite the function in power form as 4x square minus 7 power 1 over 2. Applying the chain rule, we bring down the power, keep the inside the same, decrease the power by 1, and multiply by the derivative of the inside, which is 8x. Simplifying this gives us our derivative f prime x equals to 4x over square root 4x square minus 7. Next, we set up our values. The target point x is 2.01. So we need to choose a nearby, easily calculable base point, which is 2. The small change, delta x, is the difference between them, which is 0.01. Now, we apply the differential approximation formula, which is f 2.01 almost equal f2 plus f prime 2 multiplied 0.01. It will give us square root for 2 square minus 7 plus 4 multiplied with 2 over square root 4 multiplied 2 square minus 7 multiplied with 0.01, and the final answer is 3.027.
Hi, my name is Muhammad Arif Izzuddin, and now I will solve question 2 and question 3. For question 2, the question says use implicit differentiation to find dy dx of e to the power of 2x equal to sine x plus 3y. First, we need to differentiate all the numbers in the equation. On the left side, it will be 2e to the power of 2x, and at the right side, it will be cos x plus 3y multiplied by 1 plus 3 dy dx. Then, we expand the right equation, so it will be cos x plus 3y plus by 3 cos x plus 3y dy dx. Next, we move cos x plus 3y to the another side, so it will be 3 cos x plus 3y dy dx equal to 2e to the power of 2x minus by cos x plus 3y. So, we move 3 cos x plus 3y to the right side, so it will be dy dx equal to 2e to the power of 2x minus by cos x plus 3y over 3 cos x plus 3y. And that is the final answer for question 2. Next, we go to the question 3 that is using implicit differentiation too. So, we need to find dy dx if y to the power of 3 plus 2xy minus x to the power of 4 equal to cos x. First, we need to differentiate all the numbers in the equation. On the left side, it will be 3y squared dy dx plus 2y plus 2x dy dx minus 4x cubed equal to negative sine x. So we need to move the dy dx only on the left side, so it will be 3y squared dy dx plus 2x dy dx equal to 4x cubed minus 2y minus sine x. So we factorize the dy dx, so it will be dy dx multiplied by 3y squared plus 2x. Next, move 3y squared plus 2x to the right side. So it will be dy dx equal to 4x cubed minus 2y minus sine x over 3y squared plus 2x. That is the final answer for question 3.
Hi, my name is Muhammad Hamdi Zarif. Let's jump straight into question 4. We are asked to find the derivative dy over dx for the function y equal to s times e to the power of 3 times x. Looking at this expression, we can see that y is made up of two distinct functions multiplied together, a linear term x and an exponential term a to the power of 3x. Now, whenever we have two functions multiplying each other, we must apply the product rule. The product rule formula states that if y equal to uv, then its derivative is u times v prime plus v times u prime. To make this simple and avoid any messy algebra mistake, let's break it down into pieces by defining our u and v on the side. First, let's see u equal to x. Differentiate x with respect to x give us u prime equal to 1. Next, let's set v equal to e to the power of 3x. To find v prime, we have to apply the chain rule to the exponential function. The derivative of e to the power of 3x is the function itself multiplied by the derivative of its exponent, which is 3. This gives us v prime equal to 3 times e to the power of 3x. Now that we have all 4 pieces of our puzzle, all we have to do is plug them directly back into our product rule formula. Let's substitute them in x times 3 times e to the power of 3s plus e to the power of 3s times 1. When we clean out the terms and multiply them out, we get our final derivative 3 times s times e to the power of 3s plus e to the power of 3s. Now, let's transition from multiplication to division as we move on to the question 5. Here, we ask to find the derivative f prime s for a rational function fx equal to 2 over x squared plus 3. Because this function is written as a fraction where one expression is divided by another, we need to employ the quotient rule. The quotient rule tells us that if a function is structured as fx equal to u over v prime, its derivative is given by the formula fx equal to v times u prime minus u times v prime over v squared. A good trick to remember the order of the numerator is the classic calculus rule: low d height minus height d low over the square of the box below. Okay, just like we did before, let's list out our component clearly to prevent any simple arithmetic error. Our numerator is u equal to 2. Since 2 is a constant, its derivative is simply u prime equal to 0. Okay, for our denominator is v equal to x squared plus 3. Using the power rule, the derivative of x squared is 2x and the derivative of 3 is 0, so v prime equal to 2x. Okay, now let's plug this piece carefully into the formula. Okay, so substitute our value give us x squared plus 3 times 0 minus 2 times 2x over x squared plus 3 squared. Okay, now this gives us our final simplified result. f prime x equal to negative 4x over x squared plus 3 squared. and that is our completed derivatives. This tells us that the z slope of the tangent line at any point along our original curve. That's all from us. Thank you.